Editor released in February of 2023. During the live stream announcement, Bard immediately hallucinated and crashed Google's stock by 9%. And all the experts told us Google was collapsing under its own bureaucratic weight. And yet somehow this week they may have just pulled off the biggest Mongolian reversal in history with the release of Gemini 3. Unlike the Bard disaster, the Gemini 3 release pumped Google's stock by 6% to an all-time high, and they became the overwhelming favorite to have the best AI model by the end of the year. In today's video, we'll find out if Gemini 3 gets us closer to the singularity, or if Bard just got its hands on some of Brian Johnson's magic mushrooms. It is November 21st, 2025, and you're watching The Code Report. Back in my day, all the gifted kids would get their wiggles out by holding Beyblade battles in between Johnny Bravo reruns, but nowadays all the cool kids are designing elaborate benchmarks to test the capabilities of the latest AI models. Like imagine you needed to know which AI model was the best at detecting silhouettes of Pokemon, or which was the best at managing a simulated vending machine business, or which was the closest to general intelligence and therefore most likely to use our meatbag bodies as an energy source. Regardless of which one you choose, odds are Gemini 3 Pro is at the top of the list, and it's not even very close. It swept all the major LM Arena leaderboards, took the top spot on Weird ML, Humanity's Last Exam, Math Arena, and many others. Now, I know Trust Me Bro benchmarks aren't everything, but it's been a minute since we've had a new model release dominate across so many of them at the same time. And if you don't really trust benchmarks, AMP just replaced Claude with Gemini 3 Pro to power their coding agent after they realized it did everything Sonnet 4.5 did, but better. That's impressive, but the AI war is still raging, and Gemini 3 wasn't even the most interesting announcement from Google. They also unveiled a brand new technology called anti-gravity, a new electromagnetic propulsion device that allows cars to fly just like in Back to the Future too. I wish that were true, but no, anti-gravity is actually just another VS Code fork designed for agentic coding with Gemini. You might remember back in July when the co-founders of Windsurf suddenly ditched their employees and with a non-exclusive license to the tech joined Google in a $2.4 billion deal. We haven't heard much about it since, but this week we're finally seeing the aftermath of that with the release of Anti-Gravity, a new agentic development platform led by the former Windsurf co-founders. According to the announcement video,
congratulations! You have been elevated to a manager of agents.
In other words, the AI figured out how to use you as a meatbag energy source before it even got to AGI. My favorite feature is when they forgot to rename Cascade, which is the name of Windsurf's coding agent. And yes, if you're following along at home, it's turtles all the way down. Their biggest competitor is obviously Chad, the brainrot IDE backed by Y Combinator. Unlike every other editor, Chad integrates your brainrot vices directly into your agentic coding workflow, allowing you to gamble, watch TikTok, or even swipe on Tinder while your agents do work for you in the background. Next on the list is Google's other editor, IDX, which unlike Anti-Gravity is web-based. Oh, never mind, it looks like that's dead, and it's now called Firebase Studio, which accelerates your entire development lifecycle with AI agents, which is kind of like Google's other editor, Jules, which is an autonomous coding agent, which is nothing like my preferred editor, Notepad++, but all of which could probably use some help from the sponsor of today's video, Mobbin.com. I've been using Mobbin for 5 years now, and what they do is provide highly detailed breakdowns of every screen in thousands of popular applications. You can analyze specific UI elements or entire user journeys for things like onboarding and checkout, then copy and paste the whole thing into Figma to kickstart your own design. Mobbin also just launched a collection of animations which shows you all the whimsical interactions used by the most successful apps in the world to get our smooth monkey brains hooked on their products. Give Mobbin a try for free right now and use the link below to get an extra 20% discount. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Hello, Adam. James is here as well.
I
Let
can
me
hear.
Okay. Last week, we had Nicholas, Albert, and Keaton who shared the code. So we'll get the other people to share it today. But beforehand, I'll just share my screen. 1 second. Can you guys see my screen? 1 second. James, here is the link to the code. And last week we started off with alpha beta. We finished the alpha beta function and the AI move function. Now we moved on to Minimax, I believe. Do you guys know where we left off? If not, I think it was halfway through Minimax, so we'll get the next person to finish it off. So, since last week, Nicholas, Albert, and Caden went. So let's get Adam. Can you share your screen while James is copying the code?
Oh, I'm downloading it.
Oh, okay. You can have all three scripts, but you mainly only need the Minimax base for now. And the expect max, because we already finished the alpha beta. I'm pretty sure. Hayden, I think you went last time, right? What was do you know where we left off? You don't know? Okay. Well, then we'll just continue from Minimax. So, yeah, it's the Minimax. That is the first one. So if Adam or James, whoever finishes first, can share your screen.
I would like download it into the rep. You can just copy and paste it, the raw code. And
Yeah, you don't need to download it. And thank you, Kaden. Yeah, no worries, James. Everyone here is learning anyways, so. And there's like no test as well. So whenever you're ready, can you share your screen? And then we'll go through it together. So let me explain it to you.
yeah, I copied it.
Who is the one sharing the screen? Is it James? Yep, James is. Okay. So James, let me actually show you, since you don't understand the code too much. I'll just show you how it works. So Minimax, basically we're trying to create an AI that will play as the opponent in our tic-tac-toe game. So basically what it does is we will call this AI move, which uses the Minimax. The AI move will basically choose the best move for the AI using this Minimax function and return the coordinate of the highest scoring move. And the Minimax function basically takes in the board, the depth, is maximizing and then who the players are. So first we check if the game is won, lost, or drawn. If the game is not finished, then we look for all legal moves. And for each move, we want to try it out, see what the result is, and undo it. And then at the end, we want to return the score of when we applied this move. And we keep on doing that until we get the highest move. And that will be our AI move that we play for the AI. Yeah. So if you can share your screen again, and then we'll go ahead. James, when you're ready, you can share your screen. And I guess we can do the AI move function. No worries. Take your time. And then after the Minimax, we'll head on to alpha beta. I wouldn't recommend using PyCharm because just VS Code is way better than PyCharm. So when you get a chance, I would just uninstall that and just run VS Code. But for now, let's use PyCharm. Okay. So what you're going to implement is the AI move function, which is on the bottom. Yes, that one. So basically, you see the number 1, 2, 3, 4. Allow editing until like, cancel. Click cancel. Yep. Okay. Okay. Sure. And once you're done, you'll have to reshare your screen to the VS Code. Do you need more time? Because I'll just get Adam to do it first then. Okay. Adam, can you share your screen?
Okay.
And we'll go ahead and implement the AI move function. Thank you. And it'll be on the bottom part.
This part.
Yep. AI move. So as the 1, 2, 3, 4 says, first you want to initialize the variables for our game. Second, we want to go over all the free squares. And for each square, we want to simulate the AI. We want to call the Minimax function. And then we want to undo the move. And then if the score is better than the best score that we will be keeping track of as a variable, we'll store it, replace it, and move on to the next move. And at the end, we want to return the best move. Make sense?
Mm.
So let's go down to AI move. We'll be implementing that function. Go under the doc string. You see how right now you're over the doc string? You want to go under it. So the next line, yep. 633. Enter. Yeah, that's where you want to do it. So let's make the variables. What kind of variables do you think you'll need?
Mm. Row and column.
Yeah, that could work, but the only two variables that we need for the outer loop is the best score and the best move, because that will be what we want to return to the player or determine what to return. So let's make those variables. So let's make the best score variable first. And we want to set that variable. What do you think we should set it to? We want the best score possible. Do you have an idea?
No, I don't have an idea.
Okay. So since we want the best score possible, we want to start off with the worst score because each better score, we want to replace this worst score so at the end we'll just arrive at the best score. Because if you set it to the best score to like infinity, then you will never replace it because infinity is the greatest.
So
So
we
in
see
terms
the
of this, the worst score that you want to set it to is negative
negative
infinity.
infinity.
Yeah. So do you know how to set it to
Mm.
negative infinity? Yeah, math function could work, but another one is just doing minus float.
Minus what?
Float. Float. At bracket is a function. Inside the function, you want to put infinity. INF. In string, as a string. Yeah. So it basically interprets INF as infinity. That's what float of inf returns, and we make it negative. Make sense?
Yeah.
Now we want to set the best score, best move. Now, one thing here, because we don't actually have the whole, oh, you do actually have the whole file, I think.
The what?
So here we have a literal.
Oh,
So what do you think we should set best move to? Do you have an idea?
where do we send it to?
What did you say?
What do we set it to?
Uh, let's set it to -1, -1. Yeah, exactly. Because that is not a coordinate. So when we replace it, then it'll be fine. And next, what does it say? We initialize the variables. Now we want to iterate over all the free squares. So let's first get the free squares. Do you know how to get the free squares?
Hmm, I don't know.
Okay. So first, let's set the variable name. So let's do like free squares, free underscore squares. So this is a variable. We set it using equals, and then we call the function that we already made. Let's go up and check if we have the function, get available moves.
Up to where?
Uh, it should be, let's just scroll up until we can find it. So up, 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 up. There, down, down, down. 360. So that's our get available moves that we already implemented. We pass in a board and we return a list of move. Do you know what move is as a type? If not, let's go all the way up to line 0. There should be a literal called move already defined as a tuple of int and int. So let's go all the way to the top.
All the way to the top.
Yeah,
There was nothing here.
what the? Okay. But yeah, basically it should be there. I think replit, some of your lines are not being parsed well. But yeah, let's go back to where our AI move is, which is all the way down. Yep. So let's just call our get moves, get available moves function, and we want to pass in the board. And thank you for actually typing it out and not pressing tab. Yep. So that's the available moves. We want to iterate through it. You know how to iterate through it? So like the AI suggests, we want to go through it using the row and column. So free squares basically returns a list of move, where move, I already said, is a tuple, right? Of int and int. So basically we're getting each element from free squares, which is tuple, parsing it as R and C, where each R and each C is an integer. Does that make sense?
Yeah.
It's basically a coordinate of that free square. Now, using that, we want to do the next thing, which is number 3. For each square, you forgot a colon there. For loop, we always end it with a colon. Yep. Now, for each square, we want to simulate the AI plane there. So we want to imagine that the AI played on this square. Do you know how to do that?
No.
Okay. So basically, do you know how to access the RC square? So the board's R row and C column. Yeah. So this basically says go to this cell of, so in that board, go to the R row and the C column, which is that one cell. Now we want to set it, so equals, and we want to set it to the AI player. So we're setting that cell and making it so that the AI player played on that cell. Does that make sense?
Yeah.
Okay. Now with that, what do we want to do next? We want to call Minimax and get the score. So like that suggests we want to set score. Since we're getting the score from the Minimax function, we want to call Minimax. What do we put into it? You see that docstring when you hover on it? If you hover on Minimax, you see the docstring. It says it passes in the board. The def is maximizing, and then the players. So let's put that in the arguments. So the board, and then the depth. The depth at first is 0, but each time we call Minimax, we add by 1, which we already did last week with Minimax, the function. Although I think we should still go over it again because I'm not sure if everyone here remembers that. So we pass in the false, as in who the maximizing player is. And then we pass in the AI player and human player, which we already have passed into this AI move function. Okay. Now we want to undo the simulated move. Do you know how to do that? Do you have an idea about how to undo the simulated move? Because if
Set
you
it,
see, Mhm.
set board RC to 9.
Yeah. Do you know why though?
So that if you set it to 9, then it's simulating if no one played there.
Yeah. But it's also because we set right before it for it to be AI player to simulate it.
Mm.
So since we're simulating it, we want to just revert it back to its original form. So next, we want to check if the score is better. So if the current score is better than the best score, then we want to Set the best score and the best move. Set the best score, now the best move. Yep. And then return the best move at the end. Would that work? What happens if you place the return there? Do you know?
No.
Okay. The reason you don't want to put the return over there is because it's inside the for loop. If you put it there, then it will do one round, one loop through it, run into that return, and then exit out of the function. Whereas the whole point of the for loop is so that we iterate through all the free squares, not one square and then return. Does that make sense?
Yeah.
Okay. So any questions here?
No.
Oh, did we do this part? Then do you know if we finished the minimax function? Oh, okay. Okay. Adam, you can start sharing and James, if you can share it. Okay. Okay. We just finished the AI move function, so let's do the minimax. Although I do think we finished this last week. Can you guys correct me if I'm wrong? Okay. Since no one responded, I guess we can do this. So go down to after the docstring, or let's read the docstring actually. So basically what you want to implement is you want to check if the game is over, which is either it's a win, loss, or draw. And then if the game is not finished, we want to check all the legal moves. Then for each move, we want to make the move and then check if recurse if the up with the opposite player undo the move, and then we want to return the maximum score. Does that make sense? Somewhat. Okay. Let's just so if you look at the to-dos, I have it laid out for you. So let's go to line 40. Or yeah, you can go there. Up to you. You want to call check winner? So one thing here, you want to always try and set a variable to a function that you're calling. Yep. So one thing, you're getting these errors because you don't have the full file with you. Here. Give me one sec. Let me share you. Week 2, solution. So if you go here, just copy it and then paste it to the top of your file. Now, for everything under that, you see from 200, line 200, copy it. Everything under it. Copy, delete it, go up to AI move function. Should be right around there. Yep, right there. Delete it, the whole function, and paste it. Yep, there you go. Now you'll see that there's no parse error. So let's go down to check winner. Okay. So yeah, compare it with AI player and human player because you want to check who won, if someone won. So let's do that. So first you want to check if winner is AI player. And AI player is not a string, it's a variable. So if you look at the top of Minimax, if you see the function header, you see that AI player is being passed on, right? So you'll use it as a variable. Now, when it's the AI player, we want to return let's do like 10 minus def. So 10, just the number 10 minus the depth, how deep it is in that recursive. Yeah. So this is if the AI player won, then we're returning 10 minus depth. Or else if the human player won, we want the opposite. We want a negative number, which is depth minus 10. So if you guys don't understand why, this is because we're trying to maximize the AI player. Because currently we're trying to make the AI move the best possible for the AI, not for us humans. Does that make sense? That's why we're playing as human is negative points and AI player is positive points. Okay, let's see if it's a draw now. We want to check if it's a draw. So one thing here, we actually have a function for checking if it's a draw. So let's let's go up to the function. So go up to the function name is draw in is underscore draw. Uh, go. You see that Control F. Go bottom arrow, bottom arrow. Yeah. Oh yeah. So you pass in the board and it returns a Boolean. So it returns if it's a draw. So you don't need to check if the winner equals true or false because that wouldn't work. So what do you think we should call if draw is draw? Yep. What do we want? Oh, yeah, you can also do that. And then colon. Uh, yeah. But usually you don't need to do that. But yeah. And then you want to return 0 because nobody won. So number 2, if the game is not over, we want to do it for first we want to check if it is a maximizing, if we want to maximize. Yep. Oh, it's already done for you. Okay. Delete the pass. Now we want to initialize the best to negative infinity. Since it's the AI's turn and the AI wants to maximize, we set the best to negative infinity, which is the opposite, so that we can keep replacing it. Equals, do you remember how Adam did it? Oh yeah. Do negative. float, float, float. And then as a function, we input as an argument. Quotation is a string of INF, which means infinity. So float function basically parses this as infinity, returns infinity, and we set it to negative, so it's the negative number. So it's the least possible number. And now we want to loop over it, the available moves. So next line, how would you loop over the free cells? Yep, for loop. So let's implement that. Do you remember the function that we call? Okay, so if you look at the line 178, so we use the get available moves board function. Now, if you want to go find it, so this will help you see how to implement it. So we call it with board, and what does it return? It returns a list of move. If you control and click on move, it will show you what move the type is, and it says it's a tuple of int and int. Basically, it's the row and column as a tuple. Does that make sense? So it's a list of these tuples. So we want to iterate through it. How would you implement the for loop? Oh yeah, that could work. But a better way, since we already know that it returns a row and column, or like a tuple of int and int, and we want to parse it as a row and column, you can set for I, replace I with row call. Because it's better to parse it along the way rather than after doing the for loop and setting it each time, right? Yeah, all right, yeah. And you don't want to do, if we do it this way, we don't want to do range of length of. We want to delete that. We just parse the get available moves right away. So get rid of the range. Yeah. Does that make sense? Does this line make sense? Okay. Next, what do we want to do? We want to set or place the player in that cell, the AI player. Do you know how to do this? And there's no function to do this. Do you know how we would set the AI player into that cell? Yep, change the board. How do we do that? If you can implement it. Yep, use that board. Yeah, it's the it's a well, it says it's a 3 by 3. It's a nested for loop. I mean, nested list. How do we set the board's row and column to AI player? As in, board's row and column is that cell. Yep, you got the right idea. Yeah, good job. You can just set it to the variable, right? Because you already get the AI player. So if you hover on AI player, it tells you that it's a string, and you basically tell it if it's X or 0 at the start when we do play game, I think. So next, what do we want to do? We want to call Minimax. One thing here, whenever we call a function, if you hover on it, you want to see what it returns. It returns an integer. And basically this integer is the score, which it will tell you if you hover on it. And what do we put into this? We want to put in the board depth, is maximizing AI player, and the human player. So board depth. One thing here, for depth, we want to add 1. Because each time we call it, we're actually adding a depth, right? That wouldn't work, right? Do you know why it wouldn't work? Yeah, actually, it will actually not change it because you're not setting it, right? If you were to do depth equals depth plus 1, then it would change it. But since you're just doing depth plus 1, it doesn't actually change anything. Does that make sense? Okay. Is maximizing is maximizing should be a Boolean. So while it is a Boolean, you should do it the opposite, right? Since we already maximized the AI player, now we want to minimize for the human. So what would be minimizing Boolean value? False. Yep. Good job. Now we already have the AI player, human player. Yep. Good job. Now we want to undo it. Do you know how to undo this simulation? Yeah, one thing here though, if you go all the way up to line 0, one thing you can do is control top arrow. But yeah, anyways, line number 16. Actually, my bad. Line number 23, initialize board. What do we initialize the values in that function for? None, right? So instead of the empty string, we should do none. Does that make sense? Okay. Now we want to set the best score. I mean, move. We want to set the best score. Best equals, well, remember we already have that best variable set to negative infinity. Now we want to set it to, do you know how to take the biggest between the best and the current score? Yep, good job. Now we want to return the best score. Yeah, good job for doing it outside the for loop. Now let's do the human's turn, which is the else statement right there. Now we basically do the same thing, but the opposite way. Yeah, sure, we can do that. Although you forgot one thing, right? What's above the for loop? And should it still be negative? Yeah, good job. So yeah, we get the row and column, and then for each cell, we want to set it to human player. Now, what is different about the minimax function that we call? True. Good job. Now, there's one more thing that you have to change. You're the human player, and you're trying to. Are you still trying to maximize? Yeah, good job. But yeah, that's actually it, right? So let's actually, because you don't have the AI move function, right? Yeah, you don't. Okay. One thing I can do, actually, I'll just show it to you guys now. So you can stop sharing your screen, and I'll share my screen. I will basically copy and paste the exact code that you guys have into the tic-tac-toe that we already have, and I'll show you how it should work now. Share my screen. Can you guys see my screen? Please let me know. Yep, okay. So this is basically the tic-tac-toe CLI that you guys had. And I basically just did the same thing, replaced the AI move with the minimax and the AI move function. And I'll just run it. Run it again. So now our AI will never let us win. So can you guys type in the chat a move that I should play? So good thing it aired out. It did. Please enter a number from 1 to 9. Now 1, Hayden said. So now the AI chooses square 5. What's the next move if you guys want to choose? 3, 3, and the AI choose 2, which is good. It stopped our attack. What's the next move? 8. We did 8. AI did 4. Now what's our next move? 6. And yeah, that's basically game, right? We tied, and we can never win against this AI. We can always only draw or lose, basically. You guys can always feel free to try to beat this game. I'll post give me one sec. I'll post this solution inside the solution folder, this one, and it'll be in week 3. So if you guys ever want to try it out, it'll be there. So let's just create the file. Let's do Minimax solution. Week 3 solution. So now that's done. So like I said, if you guys have Git set up and clone this repository using just one line, then you guys can just git pull and get all the code right away instead of copy and pasting all the time. Is there anyone who actually did set up Git? No one? Okay. Next, we'll move on to the next function, which is alpha beta pruning. Have you guys heard of this before? GitHub is not really Git. It's more like a visual interface for Git. But yeah, does anyone have remember doing any alpha beta pruning or have heard of it before? I know I showed you guys a video last week. Do you know what the main difference is between Minimax and alpha beta? Does anyone know? Spelling? Yeah, but Minimax is also here a bit. It just adds on to the alpha beta. Does anyone else have an idea for what is different between the two? Or like the main differences other than the spelling? Okay, I'll just tell you then. So basically, alpha beta, you guys already know. I mean, I just told you, but Minimax you can almost never beat. Then why would we want to make another AI function if we already have something that we can never beat? Well, when we go into like chess, which has a lot of optional moves, and the tree becomes bigger. You guys know what the tree means in this case, right? The action tree is all the possible. Okay, you guys know? Well, the main thing about alpha beta is we want to reduce the number of branches we perform. So instead of since we have 50 options, let's say in a chess game, we don't want to go for all 50 options. We want to try and cut that down. That's basically what alpha beta pruning is for. It's for minimizing the time spent on thinking and making it still good enough so that it will beat you every single time. So we'll start implementing the minimax alpha beta function. So basically the same thing for AI move here. We get the board, we get the AI player, we get the human player. Some differences, I guess, are here. So we basically set the best score to negative infinity like before. We have the best move. We go through each available move, row and column. We simulate the AI move. We call alpha beta pruning. So something different here. We pass in the board. We pass in the def, alpha and beta, which are the score minimizer and maximizer. We want to check if it is maximizing, which is for the AI player, and minimizing for the human player. And after that, we want to undo the simulated move like before, and then return the best score. This is not that much change. And minimax with alpha beta pruning. Here's the function. We want to check, like, this is the usual terminal state handling. We want to check if there's a winner, if there's a loser, if there's a draw. The main logic is here. We want to check if it is maximizing. We want to set the value to negative infinity. We want to go over each empty cell. We want to place AI player and then call it again, like before. In Minimax, we always call it after simulating a move. We undo the move, and then we keep updating the value and the alpha scores. And the main logic is here. When do we want to cut off this branch is when alpha is greater than or less than beta. I mean, greater than or equal to. And then the opposite, is when it's the human's turn. We want to set it to positive infinity, go through each legal move, check who the maximizing is. We want to set the value, set the beta, and now it's the opposite here. We only break off if beta is less than or equal to alpha, and then we want to return the value. Make sense? At least a bit. Then I think we already went over everyone since 3 people went last week, 2 people went this week. Let's go ahead and start off with, let's say, Caden, if you can open that up. Or actually, Albert. Let's go alphabetically so that we can remember. Albert, can you share your screen with alphabeta.py? Yeah, we're not using Minimax anymore. We're implementing a new AI function. So we already implemented the Minimax. Now we're making the alpha beta pruning. I want you to implement the AI move function, which is actually similar to the one we had before. So let's go down. I think you're in the wrong file. I don't think you have the file. Let me share you it. Here you go. And while he does that, others can copy and paste from there as well. So all you need to do is copy that. And we'll make that AI move function on the bottom. So first, you want to delete that pass. Yep. And you want to set the best score to negative infinity. So the set is not a function. You only want to set the variable best score to negative infinity. So one thing here, at the beginning of the sentence, you see the set. Yeah, that's not a function, and it will error out the code. Even there is basically no difference. It's just using one or the other, like the library. So if you do math, you'll have to import it, whereas float is built in. Uh, uh, I don't think function or set is a thing you can, it's not Python language. So we'll delete it. Delete function. So we'll delete the function. Yep. And then we want to set the negative infinity, right? Infinity is not a function. Do you remember how to do set a variable to negative infinity? Yeah. And then what else do we want to do? If you look at the to-do, we want to set the best score to negative infinity and the best move to a dummy. Yeah. Basically that. Now what do we want to do? Yeah, you could do that. Although, do you understand what? Just do four spaces. And then let's implement the for loop. We're doing for each row and column. Oh, yep. Row, row, comma, column, in. So, yep. Get available moves. And then we input the board. Since it's a for loop, we want to end it with a colon. Although one thing here, do you understand what it's doing here? So what does get available moves return? Yeah. But what kind of type is it? Python type. So it's a list, and it's a list of tuples. Do you understand that? Where each tuple is a move? Yeah. Okay. The first element of that tuple is the row, and the second is the column. Okay. Next, we want to simulate the AI move. Do you get that part? The board's row column? So we're accessing the board's R row and then the R row's C column, which is that one cell, and we're setting it to AI player to simulate it. Does that make sense? Okay. Now we want to call the function Minimax. Yep. So we pass in the board, we pass in the depth, which is 0, and then we pass in the values that we want to input into it, which is the alpha and the beta. Then we pass in the is maximizing, which is false, AI player, and then the human player. Now we want to undo the simulated move because we set the AI player. We want to undo that. Okay, yeah. Now what do we want to do? you can do that, but basically we want to check if the score is greater than the best score. If it is, then we want to replace the best score and the best move to the current one, right? And at the end, what do we want to do? We're missing one more thing. Yep. At the way end, after the for loop, we want to place the return best move. Does this make sense? Does this function make sense to you? Yeah? Okay. Does anyone else have any questions about this? If not, let me write a note about what we completed this week. So for next class, Albert already went, and we finished the Minimax, and we finished the Minimax alpha beta AI move function. So next week, we'll continue on with the Minimax alpha beta function, and we'll have everyone else but Albert go on and complete it for us. And we'll end this with a Quizlet, booklet, booklet. Anyways, let me share my screen. You guys see my screen? Okay. Let me actually stop recording as well.